Welcome to the webinar, Building the Bio-Based Future of the Chemicals Industry. My name is Tiffany Hua, analyst here at Lux Research, and I will be moderating today's session. Presenting today are my colleagues Kristen Marshall, Associate Research Director, and Varsha Sitharaman, Research Associate here at Lux Research. Throughout the webinar, you can type any questions you have in the question box on your screen. Time permitting, we will answer all your questions that we can. If your question doesn't get answered, please don't hesitate to email us at questions@luxresearchinc.com and we will respond. So we can jump to the presentation and I will hand it over to Kristen.
Thanks, Tiff. So I, like many informed consumers, care about where my products come from and the impact they have on the environment, especially when it comes to high impact industries like footwear and apparel, where significant emissions come from the production of synthetic materials like nylons and polyesters. And I know I'm not alone. And because of consumers like myself, many brands like the ones on this slide here are really placing pressure on their suppliers, wanting materials with low environmental impact, demanding bio-based, renewable, or low carbon options. But the supplies for alternative materials don't quite exist yet today. So some brands are taking matters into their own hands, working with alternative material developers. Lululemon, for example, is working with synthetic biology company Genomatica on bio-based nylon precursors, for example. In fact, the team recently released a limited shirt made partially from this bio-based nylon last year. And feeling pressure, but also seeing some of the potential near-term opportunity in this, large chemical and materials companies are taking greater action when it comes to improving the sustainability of their product portfolios. So just this past April, the world's biggest spandex manufacturer, Hyosung, announced that it would be licensing Genomatica's fermentation-based 1,4-butanediol technology, butanediol being a key precursor to spandex, and it will be investing $1 billion to scale fermentation capacity in Vietnam over the next couple of years. And Hyosung says it's doing this to respond quickly to consumer demand and lower its carbon footprint. But beyond consumer and customer pressure for more sustainable products, there are a multitude of challenges that chemical companies are navigating today, spurring interest in alternative pathways to materials. From regulations of materials concern, to supply chain variability and geopolitical conflict, to the energy transition at large. And given advancements in biomanufacturing, and given things that we've seen from Hyosung and others, the question is, could the future of the chemicals and materials industry be a bio-based one? So to address this question, Varsha and I are going to do something a little bit different today. We're going to be doing a little bit of time traveling. First, we're going to take a look at a hypothetical future that depicts what some of the value propositions of biomanufacturing are. Then we're going to come back to the present to understand what the state of these technologies are today. And lastly, we're going to talk about a path forward and what is needed for these technologies to succeed. So let's fast forward to 2050 to look at what a hypothetical future could hold. For this, I asked OpenAI's DALL-E for some help in visualizing this future. So in this future, we're in Boston, which is the headquarters of Lux. We're taking a walk around Boston Harbor, and we walk past New Balance's small biomanufacturing facility. New Balance, which has long sourced materials domestically, can produce some of its own materials here. This will allow it to have greater control over its carbon footprint, as well as product quality. And for feedstock, the company could use sugars and lignin from local forest residues and paper mills, and it can get paid potentially to process municipal solid waste from the city. At this site, the company could produce nylon precursors in fermenters. Nylon 6,6 production requires adipic acid, in which the traditional or conventional route releases nitrous oxide into the environment. And nitrous oxide is a 300 times more potent greenhouse gas than CO2. So adopting a fermentation-based approach can allow to avoid these nitrous oxide from being emitted into the environment, and for low temperature production of these intermediates. So the process's overall footprint is minimal. And then depending on the materials needs, the company could produce other things with more or less the same equipment. At the site, the company could also be engaging in more novel material development for its products. For example, producing a leather alternative for shoes from bacterial cellulose that during production can self-pigment. And then you may be wondering, how could the company afford to be located in Boston Harbor? That's quite expensive. Well, to offset the high Boston rent prices, it could partner with local universities, and the facility could dedicate some space to teaching the next generation of biotech engineers. Some of the facility's space could be dedicated also to external innovation, working with startups to support development and testing of new technologies. So compared to manufacturing 25 years in the past, that was fossil-based, large-scale, and uninspired in terms of new materials development, this future paints a different story. Biomanufacturing allows for the use of local renewable resources and waste streams. This could enable more strategic production closer to target markets. And because renewable carbon sources are dispersed, it has made sense for manufacturing to be dispersed. And it just so happens that biomanufacturing processes are more favorable in terms of CapEx at smaller scale than petrochemical routes, and the replacement of multiple unit operations with a single fermenter. So rather than being large scale, these facilities are right-sized for the environment. And this has allowed for materials manufacturers or brands to be more vertically integrated, like New Balance in our example. And because much of the same equipment can be used for different processes, it could also offer some flexibility with how these assets are used. And more contract manufacturing organizations could be established to offer some flexibility for organizations to chase short-term trends. And then lastly, bioproducts could open doors to new materials possibilities and functionalities that historical material synthesis has not been able to achieve. Things like self-pigmenting materials or self-healing materials. And then AI combined with enormous data collected over 25 years, say, could serve only to enhance the ability to tap into these opportunities. So in this future, biomanufacturing has unlocked a new chemicals industry, offering renewable, right-sized, and inspired products. But let's come back to today to better understand where these technologies stand.
Yeah, Kristen, the 2050 vision seems a little unrealistic, and it is currently tough to achieve in the bio-based chemicals industry, because today, biomanufacturing has only yet to unlock a new future for the chemicals industry. Let's take a step back to look at the current innovation system in the bio-based chemicals industry and what we can learn and how we can work towards the 2050 vision. For this, first, let's recall the classic value of death concept. So the de-risking that needs to take place as a concept is developed and scaled before it can see widespread adoption at scale. And if you look at the value of death and looking at the companies, turning biobase into a business has been difficult, where failures in the biobase space have grown with companies failing to stay afloat. And this is the case for companies that have been able to demonstrate their technologies even at an industrially relevant scale. But why? Why do they not succeed even if the technology is sound? What have been the main challenges? Over the years, it has been hard to make a business case in the bio-based industry because crude oil prices have remained low, making cost of bioproducts higher than petrochemical derived products. And incentives have remained weak in terms of policy and governmental drivers. And scale up of new processes or adoption of new materials have taken longer than anticipated, making investors and the management boards impatient. But there are some important lessons and learnings and strategies that have allowed companies to survive up until today, and that will better position them moving forward. Over the past years, Lux has interacted with a number of startups, and there are 4 key lessons that I'd like to present from these companies and from the past that will help the industry move beyond the value of death journey. So the first lesson is, given how expensive bio-based pathways are, the most successful companies have focused on near-term opportunities where premiums can be afforded. That is, they're looking at small volume niche products before targeting bigger opportunities. At Lux, we found from nearly 2 decades of interviewing startups that the most successful startups try to achieve profitability before scale. And one example of such a strategy is Global Bioenergies. So the company has developed a technology to produce bioisobutene, which can be used as an unmodified additive. And here is where Global Bioenergy strategy is to target markets more progressively. So they're looking to target the cosmetics industry first, and then the chemicals and the fuels industry. So the company launched its own makeup brand called Last in the summer of 2021 to demonstrate the value of its ingredients and secure revenue in the near term. Now, as it continues to scale towards its commercial facility, the company has also set eyes on large volume applications for bio-based isobutene, such as the sustainable aviation fuels market. Now, again, the companies still around today have mitigated a lot of risks by taking incremental steps to bigger opportunities. The second lesson is, if you look at introducing a novel product, it requires significantly more market development work, which often takes decades. And bridging the materials product gap has been a historical challenge for bio-based products, where despite having superior or unique performance, it does not always guarantee adoption. And one of the most important factors for near-term adoption of new materials are incentives that encourage the replacement of incumbents on the market. Otherwise, why fix what isn't broken? There needs to be a clear understanding of the applications that a novel material is best suited to address. A good example of a company that's looking to introduce a novel product is Mango Materials. Mango Materials produces PHAs, which is a type of a bioplastic, via a fermentation process using methane as a feedstock. Now here, Mango Materials is positioning these PHAs for polyester application, because today polyesters are one of the main sources of microplastics in the environment, and it's looking to tap into this industry. Now, solutions such as PHAs for polyester applications are becoming more compelling as regulations around microplastics continue to emerge, and when brands make more commitments to address microplastic pollution. Now, in this case, material developers are smart to identify where policies encourage the adoption of alternatives. The third key lesson is on feedstocks. So feedstocks contribute to a large portion of the overall production cost, often over 50% of the overall production cost, which is why forward-thinking companies are investigating ways to lower costs, and many are focusing on feedstock inputs. A good example of this is a company called Bluecon Biotech, where it has developed a one-pot fermentation technology to produce lactic acid from agricultural waste feedstocks. Currently, as most of you know, lactic acid is produced using first generational sugars and have deemed to cause negative environmental impacts such as land and water use and loss of biodiversity. And now, more than ever, sugar prices are skyrocketing. So here is where the company is tapping on agricultural waste residues that are available and inexpensive relative to first generational feedstock streams as an aim to lower the cost of lactic acid, but also lower the carbon footprint relative to using first generational sugars. The last key lesson is on large player involvement. Many of these startups today that are deemed successful have associations and partnerships with large companies to help them scale and commercialize their products. Genomatica is a good example here. Genomatica has developed a fermentation-based production route to produce bio-based intermediates and chemicals. And as Kristen mentioned earlier, Genomatica has developed a technology to produce bio-based butanediol, which is a precursor for spandex and other applications. Now, to scale its technology, Genomatica is primarily taking a licensing approach where it has licensed its technology to Core, which is a joint venture between Cargill and Helm, and more recently to Hyosung. Now, by taking this approach, Genomatica is transferring some of the scale-up risk to players that are better equipped to take it on. Large companies have the financial resources, they have access to a wide range of corporate partnerships, and the ability to scale the processes. As once quoted by a senior innovation leader at a panel discussion at the Lux Forum in Brussels, startups are the brains of an innovation, but corporates are the muscles. So, Kristen, you see right now, companies in the bio-based space are trying to think how they'll make it to next year, let alone 2050. There are some clear lessons from the past that can put startups in the bio-based industry on a better trajectory today, but there is more work that's needed to move these technologies forward to the vision that you painted.
Thanks, Varsha. So I'm getting, as it stands today, while there may be opportunities here and there for bioproducts, a lot would need to happen before we see widespread adoption. But let's revisit this valley of death image and consider some of the challenges that you addressed. And let's think about how external elements could help de-risk the journey for technology developers to be able to capture that value that biomanufacturing has to offer. So first, in this early concept portion of a technology's journey, it's unsurprising to see startups in the biotech space spinning out of universities or in proximity to universities like Harvard or MIT, of course, where ideas are being generated. But in this nucleation phase, it's not just important in terms of coming up with ideas, but in terms of evaluating their potential. It's helpful here to be able to get inputs from industry, to be able to identify what the market needs are and whether a technology is worth pursuing. Just because something can be made bio-based doesn't mean that it should or that the value proposition is strong enough today. So this is where it's really helpful to foster environments where startups, industry, students can come together, like iGEM, for example, or Ginkgo Bioworks Ferment Conference that it holds every year. And then to be able to execute on these ideas, it's really important for technology developers to have both access to R&D facilities, but also piloting resources. Now, when it comes to R&D facilities, as we all know, developing materials technologies isn't the same as digital technologies. The overhead and costs of R&D are much more expensive and time-consuming, especially for synthetic biology platforms. And for early stage companies, this is where incubators like IndieBio can come in, providing wet lab space, equipment, mentorship opportunities. And there's also organizations like Ginkgo Bioworks that I mentioned a little bit before that offer enzyme design and strain engineering services to accelerate development timelines. And in Ginkgo's case, they do this in exchange for royalties if a product is scaled. And I would say that for this early R&D stage, there's already a decent amount of support at this level. But when it comes to the scale-up support and piloting resources, I would say that there's historically been a dearth here. And piloting resources, of course, are critical to be able to demonstrate these platforms. But it's really hard for startups, especially in the current economy, to secure investment and resources needed to scale. Some regions have offered more scale-up support than others. Europe, for example, has allocated significant funds in its Horizon Europe program, as well as through organizations like Biobased Europe Pilot Plant. But in the US, on the other hand, there is a well-known gap in domestic pilot and intermediate scale infrastructure here. Unfortunately, the government is starting to recognize this, and there are organizations like Biomade that have been launched with investment from the DoD to bring online bioindustrial manufacturing pilot facilities in the next several years here. And then lastly, but certainly not least, even after a technology is demonstrated, having access to cheap biomass or renewable inputs is really critical, as well as access to skilled labor for widespread adoption to be achieved. As Varsha mentioned before, biomass contributes to a large percentage of the overall cost of bioproducts. And so it's important to understand where feedstock is available, abundant, and cheap. In the United States, for example, there's a lot of interest in the Midwest for large-scale projects, and because of its abundance of biomass and existing ethanol production. But we've also seen states like Maine, which has a large forestry sector, pass tax incentives to try and encourage the growth of their forestry products industry. And we're also seeing a lot of activity in countries like Thailand that have a lot of cheap biomass available, or Japan with governments that are incentivizing the growth of their domestic bioeconomies. And then lastly, labor, skilled labor. When we talk to startups, many mention that they're struggling to find employees with the right educational backgrounds to be able to grow. And so this is another one of the reasons that Biomade, as I mentioned before, has workforce readiness initiatives to try and raise the next generation of biomanufacturing labor force in the United States. So ultimately, for more success in the near term, one of the key takeaways from covering this space is that it's important for companies to recognize that failures can be avoided early if technology developers are given more guidance or given more or are more strategic about the opportunities to go after. Who is going to buy their bioproduct? What specifications does the product need to meet? These may seem like obvious questions, but time and time again, we're finding that technology developers don't necessarily have these answers because they're not communicating enough with industry. And this is where industry can come in and can support. So in the next 10 to 20 years, there will likely be stronger business case for Biobased, driven by the energy transition and the quest to reach net zero, which is going to drive defossilization and a need for renewable carbon inputs. Regulations or national action plans are going to be incentivizing the use of alternatives, first indirectly through restrictions around certain materials, materials of concern policy, or even defense, and then possibly more directly. And then lastly, more public and private resources will go towards development and scale up. We're already starting to see that here in the United States. Biden administration's executive order on biotechnology and biomanufacturing, and the presence and launch of organizations like Biomade looking to scale up bioprocesses here. So while 25 years is far away, it's not as far away as we think in terms of putting all the pieces together.
So, Kristen, if I'm getting all this right, let me summarize our key takeaways. Biomanufacturing can unlock new opportunities, given that it will align with emerging policies on waste, emissions, and materials of concern. But today's success in the bio-based industry has been limited, and for companies to survive, they will need to be strategic about their near and long-term opportunities. But also, lastly, what can corporations do? So here is where corporates should identify startups with good innovations and engage early on to support such technologies. So thank you for your time. We are open to taking questions now.
Thanks, Kristen and Varsha. So yes, we'll now be taking questions from the audience, which you can type in the question box. As a reminder, if we do not get to your question on this call, someone from Lux will be in touch after the webinar. And so we'll move over to the questions. So I have a question here, which I will rephrase. So we talked about the past, present, and future. So, today, what should some of our audience members do for near-term opportunities in the bio-based space? And I'll pass this maybe over to Varsha.
Thank you, Tiff. Yeah, of course. So as I mentioned earlier, I think companies should focus on being strategic about their opportunities, focus on small volume, large return kind of opportunities. A good example, as I mentioned earlier, is global bioenergies, where startups are focusing on profitability first before scalability. So that's one of the strategic opportunity that companies in the space should identify.
Thank you. And our next question. So bio-based materials, they're one solution for decarbonizing the materials industry. We also have recycled and CO2 materials. How would you position bio-based against, the other sources of carbon? And I'll pass this over to Kristen.
Yeah, thanks, Tiff. So I think, yes, these are all solutions to potentially decarbonize the chemicals industry. But the chemicals industry, the commitments being set for decarbonization are nearer term than the stage of these particular technologies today with regards to bio-based CO2 and recycled technologies. So meaning that there's other technologies available that are more mature, that are more cost competitive, that I believe the chemicals industry as a whole will look to achieve their decarbonization goals. However, looking to 2050 and looking towards defossilization of the industry, given the energy transition and the electrification of industries, that's where you would look to things like bio-based CO2 or recycled carbon content. And how I would compare these to each other is really looking at regional considerations like biomass availability, access to cheap electricity, to make chemical productions through these routes make economic sense. And so that's kind of, it's looking at this problem in two different ways. One from how effective are these at decarbonizing, but then also the future defossilization consideration as the energy transition occurs.
Great, and that actually points me to my next question, the availability of biomass. Of course, there's different availabilities regionally, but we also need to consider biomass in terms of other markets, including sustainable aviation fuels. So how would you compare the competition for biomass for different markets like SAF and chemicals?
Yeah, that's a great question. And it's one we are getting asked a bit about, just as there is a scale up for SAF, what will be biomass availability or resource availability for other things. I would say it's not a concern today, just given the scale of biochemical production today. However, there are startups that we engage with that are thinking about this. It is becoming a problem for them because, for example, they may develop a platform using used cooking oil, and yet it's much more attractive for suppliers of used cooking oil to supply bigger contracts to a SAF producer, for example. So it is a one-off problem today for some of these developers, but I don't think I don't think it's for just in general as big of a problem for biochemicals production, just given the scale that it's at. But in the future, it could be more of an emerging problem for sure.
Fantastic. So I think that concludes our webinar. Thank you, Varsha, Kristen. And so the slides in the presentation, the recording today from this webinar will be sent to all attendees via email. After leaving the webinar, you will be prompted to complete a survey on today's presentation. We would appreciate any feedback you might have to help inform and improve our webinars. And yeah, on the screen, you can see here our upcoming webinars. And so feel free to check them out. And thank you so much for joining today and have a great day.